Hello and welcome to a slightly muted introduction to Lexx Education, the comedy science podcast where comedian me, Laura Lexx, tries to learn science from her nerdy younger brother Ron while her daughter falls asleep, mere meters below where she's recording. Hello, Ron.
Hello. How's it going? We're doing the intros, outros in examiner's voice today because it's chemistry exam part 1.
It is chemistry exam part 1. I listened to it today. It's very funny listening to this episode in the midst of what we're currently recording, because obviously we've turned over a new leaf with recording, as you'll have heard last week in our results episode. And then listening to this one, the leaf is on its back again.
Yeah, we've turned over an old leaf with this one, and we found the same old shit that was under all the other ones.
Do you know what I found out the other day? This is a real dumb bins moment. I think I'd just done some social media promo, and I said something about turning over a new leaf, and then said I didn't really understand it to Tom, and he was like, well, basically, cut a long story short, I didn't realise that by leaf it meant page. I thought it meant like leaves that have fallen off a tree, and it was something about like finding bugs or something underneath them.
No. I think for you, it might be about foraging in the underdirt for bugs. But no, for most people, yeah, it's like leafing through a book.
Yeah,
turning over a new
I
leaf.
understand. Yeah, that makes loads of sense. That's what Tom said, is turning over a fresh page and there's a clean page there ready to go. I was like, yeah, that makes way more sense than just turning over old leaves and looking at mulch.
I was listening to Dan Carlin again recently, my favourite King of Kings, and he talks a lot about ancient Mesopotamia. And I was listening to it, and I was like, you know what, I want a bit more. So I've been watching like YouTube videos and stuff about it, and I've just finished a 3-hour documentary on the Assyrians. And now I'm watching a 2.5-hour documentary on the Sumerians. And the Sumerians are a people that came before the Assyrians. And essentially they, because of the arid landscape of Mesopotamia and whatnot, and life really sort of clinging to the riverbanks and whatnot, it's a lot of how they sort of formed society was moving this water around and stuff. And then you had these people in sort of the lush river valleys, working this shit out, building civilization. But then you'd have kind of like the mountain people that were fairly nomadic, and their kind of harder way of life led them to be kind of, a bit more, they'd come in and take what the civilizations in the river valley had and whatnot. And I wonder where you'd have fit in that, because you wouldn't have been one of the thinkers in the valley, but I don't think you'd have been one of the hardy pups up in the mountain either.
I think I'm very much a product of the modern world, Ron. I'm an overthinker, and I think back in the day you didn't have as much time to think. Like a lot of the quandaries of modern life of trying to be kind and trying to be fair don't exist so much when you're trying to survive, because fairness isn't as important as survival. But now survival is relatively easy and it's succeeding that you're aiming for. It's hard to balance fairness and success.
Yeah. Interesting thing on that. One of the Assyrian kings, Esarhaddon, they think it is one of the first written sort of documentations of what people think was depression.
Interesting.
And he, I think under him, or... No, it was his father Sennacherib, I think, actually, sorry. His father Sennacherib, under him, basically, the empire sort of reached about as far as it ever did, down into Egypt and sort of towards the Balkans and stuff. Towards Anatolia. And he just got really depressed. And he just wouldn't leave his room for days at a time, wouldn't eat.
They had he's the one at the apex, so he's the one with more thinking time.
They had this crazy ritual that they used to do for the king, where they'd get a commoner from the town, from the streets, and they'd swap places for 100 days. And the king would go pretend to be a farmer or whatever, and this commoner would come and live in the palace and wear the crown and eat the food of the king and stuff, so that the spirits that were affecting the king would get tricked and be like, the king's here now, and get this guy. And then after 100 days, they killed the commoner and the king came back.
Oh, God.
Sennacherib wanted to get rid of his depression so badly. He did this like 4 or 5 times.
Oh, Christ. But would you do it, though? Like 100 days of great life and then death? Or just a whole life of, like...
Not if the dude walking out of there's got a face like a smacked ass.
Yeah, that's true.
The really depressed guy. No, I don't want his life.
Yeah. Does the peasant know that? I suppose they don't really have a choice even if they don't want to, do they?
No, the Assyrians weren't a kind people. Well, their nobility weren't a kind people. I won't speak for the common man.
Well, this was a fun start. So, welcome to our science podcast.
I have to keep holding myself back from suggesting we do an ancient Mesopotamia Patreon thing, because that's just listen to Dan Carlin, everybody.
Yeah, that's just this week's current interest. Although younger sister of the podcast did text me today about, do we still want to do the 2 crimes and a lie idea that I'd utterly forgotten we'd had.
Oh, yeah. And she's going to do all of the work for that, isn't she?
Yeah, we just got to turn up, baby.
Fucking sweet. Yeah, that will become the Patreon if she does all the work.
Yeah. Okay, so have a listen to this. This is the first half of the chemistry exam. It starts so dismally, both in terms of professionalism and mood. So have a good time. What have I put in the notes for this? Yeah, what do you think of the way I describe tables? Do you think it's too much? Do you think it's not enough? Why are you breathing so heavily, Ron? That's a question you've put in.
Yeah, I don't know, but there's a big bit where there's just kind of a rumbling background noise of me breathing. And it's not even because I'm like, doing it myself and sort of leaning into the mic, because it was in the table in between us. I'm just...
You're just gross.
Yeah.
Well, enjoy.
Ooh, water. You sure you don't want to get the snacks right now?
I don't know, I feel dismal.
You need them for a bit. Alright, Laura, why are we here?
Chemistry.
Time to stop revising.
I'm just getting myself a periodic table because I assume I'm allowed that in the exam.
Yes, but there is a specific one.
I feel quite dismal. I think this is going to go horribly badly, and I feel sad for me.
Says only foundation higher. Nice.
Ron, I just had a fart.
Yeah, I heard it.
I knew she'd want to come in. Listen up, Lucky Dog. It's exam conditions in here. Oh, it's you texting me. Damn. Okay.
Yeah.
Oh, it's on its side.
Rotate.
Okay. Yeah, I've rotated it now. Oh, it's not coloured in. I can't read this. Ron, it's not colourful.
Why would it need to be colourful?
To show you the groups and stuff.
I don't want to get into this right now, but that's not what the groups are.
Yeah, like all the metals are blue and other things happen.
It's chemistry today, Laura. We're doing your chemistry exam. For those that want to follow along, it's the foundation.
Doing this at the beginning today. Fancy boy.
It's the Foundation 1 2023 June chemistry paper. Laura, how do you feel?
I don't feel confident. Yesterday I finished the biology one on quite high. I think it went quite well. What's the matter with you?
Hands don't feel clean.
Yeah, why don't you fuck off now, mid-podcast?
Well, just keep talking.
So yesterday, I felt quite confident by the end of the recording. And then it sort of dawned on me mid-afternoon today that wasn't it over, that we still have to do chemistry and physics. And then I just sat down to do some revision and immediately fell at the first question. So, you know. But I've had a much better day than I had yesterday. Child of the podcast and I have had a lovely day together.
Can't abide having dirty hands.
I don't like having a greasy face.
No, both are bad.
And I also detest having dirty teeth. And even though I have cut my teeth cleaning down a lot since you told me off for it, I still like to mouthwash a lot.
Yeah, that's fine, I think, probably. Probably hurting you in a different way, like all aspects of modern life. Laura, you did really well yesterday.
We don't know that yet. We haven't done the results.
I do know that because I hold this information in my brain.
Oh. Thanks, Ron.
Today we'll do chemistry, though.
Yes.
This
chemistry, I feel like, because physics is the one I've liked the least, but I think I've done quite well on the quizzes. Whereas biology I've really enjoyed, and chemistry is just in the middle somewhere. I think I do kind of quite like chemistry. I do think it's quite cool and interesting, but it is much harder to picture than biology.
Yeah, it's a lot less
tangible,
a lot more terminology, which is where you fall down.
Yeah, go tubes.
This question is about atoms. Question
You
1.
haven't sent them to me.
I have.
No, I don't think you have. I think I've only got the periodic table. I think.
Sorry. I really thought I had.
You haven't.
I've got a billion tabs open. Several hundred.
Okay.
I've sent it to you.
Yeah, I know. Sorry, I had to reply to a message.
This question is about atoms.
Atoms.
Atoms contain 3 types of particle: electrons, neutrons, and protons. 1.1. Which particle has no electric charge?
Neutron. Jimmy.
Final answer?
Neutron.
Yes? Final answer?
Yes.
Which particles have the same relative mass?
What's this voice you're doing?
That's my examiner's voice.
Oh, I wonder how long it'll last.
Which
See if you can keep it up for the whole one.
Which particles have the same relative mass?
Oh, the options are an electron and a neutron, an electron and a proton, a neutron and a proton. The answer, Ron, is a neutron and a proton. They both weigh 1.
Final answer?
Correct. Yes.
The formula of a compound is N2O. How many of each type of atom are there in one molecule of N2O?
Now, I never understand these because O comes in a pair, but there's no 2 on that O. So I'm not going to overthink it. I'm going to say 2 nitrogens and 1 oxygen.
Okay.
And I'm not even going to let your okay get to me. I haven't had wine this evening. And I didn't want any until you said okay like that, and now I do. Whoa, everything's buzzing and beeping. Who's texting you?
Probably Judith.
Oh, I want to talk to Judith.
No, you don't.
Yes, I do.
Reply
I'm
to
going to text Judith.
Reply to messages then.
I do reply to messages. In fact... Oh no, she texted me last. I want to text you too. Whoa, she sent me a nude.
Lucky you. She's fit.
Yeah. Technically, I've been with her longer than you because I didn't break up with her for a year.
I didn't break up with her either.
I'm so curious to see if that makes the edit.
An atom of element Z contains 3 electrons, 4 neutrons, 3 protons. Give the name of element Z. Use the periodic table.
An atom of element Z contains 3 electrons, 4 neutrons, and 3 protons. Give the name of the periodic table. No, give the name of element Z. Okay, so if it's got 3 protons, that means the atomic number is 3. So that would be, and then it's got 4 neutrons, so the atomic mass, I got a message from Judith, would be 7. So that was lithium, Ron.
Okay. Do you want to put your phone on silent?
It is on silent.
Do you want to put it not on vibrate?
I don't know how to do that.
Complete figure 1. You'll need paper, Laura. You'll need paper.
Oh, I haven't got any paper. And I don't know how to turn this off. How do you turn off the vibrates?
Why don't you just put it somewhere soft?
Maybe in my butt? Do I really have to get paper?
For the paper question.
But you're the one doing the answers, so maybe you should get paper, and I'll tell you.
I'll mark it. Go get paper. It was right there.
Yeah, and I got it really fast. So, Ron, can you put your phone down then?
I'm waiting for you.
To do what? You haven't read the question.
I did. Complete figure 1 to show the positions of the particles in an atom of element Z. Use the symbols X for electron, a black circle for a neutron, and a white circle for a proton.
You didn't say any of this.
I did. I think you'll find
You're not allowed to keep picking up your phone if you've taken mine away.
Okay, I was just reading an article about raw dogging. Shut up,
Well,
Judith.
please don't. We're doing an exam. Okay, so the figure 1 is 3 concentric circles. Mackie, shut up. Nucleus in the middle. Show the position of particles. Right, okay, so I've got 4 neutrons. The neutrons are in the nucleus. 1, 2, 3, 4. Now, I always thought the protons were also in the nucleus. But then I feel like very recently you burst that bubble of belief by saying they were just near the nucleus. But I don't know about that.
She's so shit.
Did she just take like 6 attempts to get on that chair?
Yeah.
Oh, it's because there's stuff on it, so she's frightened.
Mackie, we can't have this. She's a fucking dumbass.
Don't you just love that line of skank along the window there where her nose goes?
That's so gross, man.
Yeah, I live in a hovel. So do I put them in there? I swear when we first did it, they were in the nucleus. So I'm just going to do that. I'm going to draw 4 nucleuses. No, 4 of those in there. And then the 3 electrons, I'm going to do 1, 2, 3, like that. There you go, Ron.
Final answer?
Sure. Oh, yeah. There are no questions printed on this page. Do not write on this page. Answer in the spaces provided.
This question is about acids and alkalis.
Okay.
Acids and alkalis. Pieces of potato. Acids and alkalis are substances that produce ions in aqueous solution. Draw 1 line from each substance to the ion always produced by that substance in aqueous solution.
Fuck, I've got no idea. So I've got acid and alkalis options, and I've got to connect those to Cl minus, H plus, Na plus, OH minus, and SO42 minus. What the fuck? Acids and alkalis are substances that produce ions in aqueous solution. Draw 1 line from each substance to the ion always produced. What? Draw 1 line from each substance to the ion always produced by that substance in... Draw one line from each substance, so it only wants 2 lines.
Yeah, one from acid and one from alkaline.
To the ion always produced by that substance in aqueous solution. Oh, so if you put an acid in an aqueous solution, it always produces this thing.
Yeah.
Okay, well, I now understand the question at least.
You see how you've got one column that's labelled substance and another one that's labelled ion.
Yeah,
always
I know, but when I was
aqueous
first looking
solution.
at it, I thought it was going to be like, hey, like Cl minus make, like they each make an acid or an alkali, connect them all up. So I just had to break the question down.
Okay.
And now it is a guessing game. So I am going to guess.
You're allowed 2 bits of help in this exam. You let me know when you want them.
Oh, it feels early doors. It feels early doors. What have we got? So we've got negative chlorine, hydrogen plus. I remember those coming up when we did like sticking electrons in stuff. That's sodium plus. I don't think it would be that one. An aqueous solution, so it's going to be something to do with water, I think. So it logics to me to use the OH and the H. Then, but it's just to decide. I'm going to say H plus acid, because that feels like hydrogen peroxide and stuff is often bleaches. That feels acidy to me. So I'm going to do that. And then I'm going to say OH negative for alkali, working on the logic that we're looking to use watery molecules because it's an aqueous solution. So I'm going to say alkali is OH negative.
Final answer?
It's the best I've got. And I feel like even if it's wrong, I've done some sort of logic that I can be proud of.
Okay.
Hey, let's do like an asterisk and you tell me if I've done well there. Because I really care right now.
Like an edit break and then...
But I feel like when we come to do the results, I will no longer care. So tell me if I've got that right now.
That's not the format.
Ah!
What type of aqueous solution has a pH of 11, Laura?
Alkaline.
You sure?
Yes.
Are you sure? You sure?
Yeah, I'm pretty sure.
A student determined the reacting volumes of hydrochloric acid and sodium hydroxide solution by titration.
Titration, titration.
This is the method used.
Oh no.
Measure 25 cubic centimeters of sodium hydroxide solution. 2. Add the sodium hydroxide solution to a conical flask.
Why does it have to be conical?
3. Add 3 drops of indicator to the sodium hydroxide solution.
Tick-tock,
4.
tick-tock, tick-tock.
Add the hydrochloric acid drop by drop until the indicator changes colour. 5. Record the volume of the hydrochloric acid added. 6. Repeat steps 1 to 5 3 more times. 2.3. Which piece of equipment should be used to measure 25 cubic centimetres of the sodium hydroxide in step 1?
My options are a beaker, a pipette, and a ruler. I'm going to go beaker, Ron. Tracy. Mum was telling me the other day how much she hates Tracy Beaker.
Why?
I don't know. I guess because she teaches and she is like, there's a lot of stuff in those books that's like weird to read to kids.
And she hates women. Which piece of equipment should be used to add the hydrochloric acid drop by drop in step 4? A balance, a burette, or a measuring cylinder?
Well, I don't know what the fuck a burette is, but I'm going to have to guess that because I don't think... I thought we were doing that with a pipette. Well, maybe not. Maybe nobody said pipette. Maybe I just thought pipette in my
Pipette
head.
was one of the options in the last.
Oh, well, maybe a burette is some kind of beautiful pipette. I'm
Or the type of pipette you'd find at a bureau.
Yeah. Or the type of pipette that gets stuck to your fur when you run through the fields.
Or the type of pipette that comes on top of really fancy pizza, and you're like, I'm sure this is expensive, but is this nicer than the other type?
Yeah, or the type of pipette that shot Alexander Hamilton.
Or the type of pipette that sort of what you say when you're cold, but almost.
I think we can leave it there.
Table 1 shows the results.
Okay.
Now, I think you can do better than you did yesterday.
Did you just wipe your mouth on your collar?
Yeah.
You are full trash.
It was water.
Still don't wipe it on your collar. Your collar is the most seen part of your outfit.
Well, the inside of it.
Ew! You just... Oh, you even got corner mouth crud into it.
Yeah, it's on the inside.
Yeah, but now it's just on your neck and in you.
Even my shoulder on this part of my t-shirt. It's fine.
Ugh.
Laura, just some on-the-job coaching from yesterday. I'm not a fan of the way that you've been describing tables.
No, but hey, I thought this
better.
too. Yeah.
I just wanted to give you that note before we start describing some tables.
Yeah, I think I got into my stride towards the end of the table reading.
Same page.
Okay, so table 1. I need to remember what I did differently. We've got 4 trials, and we're looking at the volume of hydrochloric acid added in centimetres cubed. In trial 1, it was 24.3. Trial 2, this is good, isn't it? 24.5. That fart smells, I'm sorry about that. Trial 3.
No, I don't think you need to give the numbers that precisely. I think, how about this? It's like, we got trials 1 through 4. Trial 3 is way higher, it's 28.1. The other ones are all around 24.5.
Oh, that doesn't feel very scientific at all.
No.
It just got to you.
Yeah.
It's funky.
But you can still use the exact numbers.
Why are you guffing the fart up into your face with that hat? You're really like scooping air from down at butt level.
Yeah, and moving it away from me.
For a while when I was little, when I first found out about how we breathe and stuff, I got really scared about getting carbon poisoning. And when I was going to sleep at night, I used to breathe in one way and then roll my head over to breathe out. And then breathe it back the other way to breathe in. And it was so tiring. I got really worried I'd suffocate when I was asleep.
This feels like one of those things you've never told anyone before.
Yeah, I don't know. I think I just forgot it until now. I wanted to have really clean hair.
You want to have really clean hair?
Air.
Okay. Write in, listener, whose table description did you prefer more?
Well, I just think yours is given away, though, because now the question is, which is the anomalous result in table 1? Well, it's result 3, isn't it? Which is just, we've shot the lemon in the head, or whatever it is. What is it? Buried the lead.
Nope.
Yeah, buried the lead.
No, we've not buried the lead.
Yeah, we have.
No, burying the lead would be not talking about...
Okay, we've exhumed the lead.
Jumped the gun.
We've jumped the gun. Because you basically gave that away at the start.
So?
Well, this is less exciting, isn't it? I think it's trial 3 one is the answer to 2.5.
Yeah. Which is the anomalous result on table 1? Laura thinks
Anomalous.
You said burette for the last one, didn't you?
I said the right answer, just note that down.
Did you say burette?
Yeah, I think so.
Trial 3. Final answer?
Yeah.
Suggest one reason for the anomalous result in table 1.
What was this again? Put that in. Add sodium hydroxide. 3 drops of indicator. The indicator changed colour. Suggest one reason. I would say inaccuracy in measurements of the solution. A broken burette? I don't know what to say. Don't say that!
I've got so far inaccuracy in measurements of the solution or broken burette.
No, don't put broken burette in. I don't even know what a burette is. Carburetor. That's something else. Go grease lightning, you're adding to the sodium hydroxide. Da-da-da, add it drop by drop. I mean, it's got to be user error, basically, but which bit's going to be the user error? 3 drops of the indicator. Maybe your dripper's broken. To the solution. Add the hydrochloric acid drop by drop. Record the volume of hydrochloric acid added. Yeah, I would say over measurement of sodium hydroxide solution.
Final answer?
Yes.
The student used a solution of sodium hydroxide of concentration 4 grams per decimeter cubed. Calculate the mass of sodium hydroxide in 25 centimeters cubed of this solution. 1 decimeter cubed equals 1,000 centimeters cubed.
Okay. Now, see, what happens here is like my brain turns into like a gif of a tsunami. And all my thoughts are the people on the beach going, ah, running away. And what I kind of have to do is let that wave of panic pass, pieces of potato, and then I can have a think clearly. I can think clearly now, the rain is gone. Okay, that's figure 1.
I've already marked
keep that as an answer sheet, and this is going to be my notes. The student used a solution of sodium hydroxide of concentration 4.0 grams per decimeters cubed. And then we've got 25 centimeters cubed of this solution. What are you typing? Who are you typing? Can't type while I'm thinking. Can't. No. No. I'm trying to think.
Think away.
Stop typing then. You know I have a fidget brain. Fidget. Felicia Darling. Do you remember that?
Felicia Darling?
Yeah, in Basil the Great Mouse Detective, that cat. Oh, Ratigan.
I don't think I've seen that in like 15 years, maybe more.
Got to go, got the uniform, got everything on the list.
I remember the film.
Yeah.
Yeah.
Okay. Calculate the mass of sodium hydroxide in 25 centimetre cubed of this solution. So, 1 decimetre cubed is 1,000 centimetres cubed. Okay.
Is this one of those times where if I try and interact, that's going to be cross for you?
Mm-hmm.
Okay.
So, calculate the mass of sodium hydroxide in 25 centimetres cubed. I think what I need to do is call that 2.5 decimeters cubed, because I am dividing... No, a decimeter cubed equals 1,000 centimeters cubed. So I have got 0.4 of a decimeter cubed of sodium hydroxide. So, okay, so.
Are you ready to give me your answer?
No, I'm thinking. Okay, so it has a 4 grams per decimeter cubed. So what I need to do is make my 25 centimeters cubed a decimeter cubed. To do that, I have to multiply it by 40. to make 1 decimeter cubed. There's 40 of those in a decimeter cubed. So then I need to divide 4.4 divided by 40 to work out what I've got in there, I think. So I believe I have got 0.1 grams of, I think it's 0.1, Ron.
Okay, you want to give me your working?
So, my working was 25 centimetre cubed times 40 equals 1 decimetre cubed. Therefore, 4.00 grams per decimetre cubed divided by 40 equals...
Sorry, 4.00
grams per decimetre cubed. 4, which is
4 grams.
the concentration. So
Yeah.
4 divided by 40 equals the answer, 0.1.
Okay. Question 3. Final answer on that last one? I imagine so.
Yeah, I think so.
Alright, question 3, Laura. Feels like we're going through this faster than the biology stuff.
How long have we been recording?
Oh, is it recording? Yeah. Oh no, it's been half an hour. Oh, goodness me. Oh, wow. This question, Laura, is about carbon. Which type of substance is carbon?
The options are compound, element, or mixture. The answer is element, Ron. It's an element. Final answer.
Yeah, not even going to check that one.
Nope.
Carbon has isotopes with mass numbers of 12, 13, and 14. Complete the sentences below.
Okay, so I've got the
Choose
two
answers from the
sentences
box.
are the isotopes of carbon have the same number of, and the isotopes of carbon have a different number of. And the answers in the box are electrons, ions, molecules, neutrons, and protons. The isotopes of carbon have the same number of... Oh, God.
Episode 2.
The isotopes of carbon have the same number of neutrons and a different number of protons,
Final answer?
I think. Because if the electrons change, it's an ion. That's what makes an ion. It wouldn't be ions. That's not part of it. It's not molecules, because we're not talking about molecules. So it's neutrons and protons. It's incredibly hard to split a neutron or lose a neutron. So I'm fairly sure the number of neutrons stays the same and it's the protons that change, I think. Yeah, I'm going to go with that. Same number of neutrons, different number of protons.
Okay. You just let me know when you want those bits of help.
Should I take some help now, Ron?
Question number 3.
No, okay.
Up to you.
I feel like you moved on.
12 grams of
Ron,
carbon.
should I get help there?
12 grams of carbon contains 6.02 times 10 to the 23 atoms. What are you Are you Googling the answer?
No. I'm asking Judith to ask you if I got that right. Is she doing it?
Look at this picture of my friend Dan from Chris and Katie's wedding.
Wow, he looks like a piece of potato.
That's a great pic. 12 grams of carbon contains 6.02 times 10 to the 23 atoms.
Okay.
What?
It's just a lot of numbers, isn't it?
Yeah. Do you know what that's called?
A carbon 12.
No. No, what? The 6.02 times 10 to the 23. Do you know what that's called?
No.
Okay.
What is that called?
Doesn't matter.
No, tell me.
I don't know. Just tell you.
Tell me.
That would be help.
Tell me.
Do you want to use this up as one of your bits of help?
No, because you teased this. This should be like that bit where Aladdin tricks the genie. Because you teased it. Tell me.
But you've not tricked me.
No, but you've slutted it.
I've slutted.
Yeah, you slutted it a bit. Either full slut the answer, or it's not even one of the questions. So
That's standard form.
oh, well, what the fuck does that help with?
No, it was from yesterday's thing where you had to give an answer in standard form.
Oh,
Yeah.
I didn't get that right then.
No, you didn't.
I didn't.
You tried to leave the word million in there. You wanted to write 315 million.
I would argue that is a way more standard form for writing things.
No, this is standardised because it doesn't matter how long the number is, you still have the same things there.
Oh, so I should have put like 10 to the 5.
Something like that, yeah.
Okay.
Which expression is used to calculate the mass of one atom of carbon?
My options are 12 over 6.02 times 10 to the 23. That reversed. There you go, Ron. Or 12 times 6.02 times 10 to the 23. It would be the middle one, 6.02 times 10 to the 23 over 12. You divide it by 12 to get the weight of a single one.
Final answer?
Yes.
Figure 2 shows diagrams that represent different forms.
Wait, is that right? That would be 1 gram of carbon, but that wouldn't be the mass of 1 atom of carbon. Oh, fuck it, it's fine. Wait, I'm so confused. Maybe it would be something else. Hang on. Would it be 12 divided by? 12 grams of carbon contains that many atoms. Maybe it would be 12 divided by... Yeah, I think it's the first one actually, Ron. First one, 12 over 6.02 times 10 to the power 23.
Okay.
Oh, we're only a quarter of the way through. Oh, fuck. How many helps do I get?
2.
No, I'm not using one here.
I'd maybe save it for one question that's worth more marks.
Yeah, okay. And I've got that one right.
That counts as a bit of help.
Okay. No, it doesn't.
You said okay. Figure 2 shows diagrams that represent different forms of carbon. Which diagram represents Buckminster Fullerene?
Ron, it's figure B, the ball of fun. Buckyball.
Can you give me the names of the other ones?
No, but they're not asked for.
Can't you?
No. Please don't be the next bit. No.
You really can't?
Well, there's a tube and a sort of atom pyramid.
It's disappointing.
Atomid.
3.5. Figure 3 represents part of the structure of graphite. Draw one line from each property of graphite to the structural feature that is the reason for that property.
Okay, my properties are a lovely 4-bedroom semi on the coast.
Nice one, Kevin.
Thank you. My properties are graphite conducts
Did
electricity.
you get that was Kevin McLeod I was going for?
Yeah, not spacey. No.
Or the dog?
The dog?
Kevin the dog?
Kevin the Big? No, that's Clifford.
Kevin the big dog.
Tried to compete with Clifford the Big Red Dog, but what they hadn't done crucially was give him a colour. So Kevin the Big Dog just couldn't keep up. Kevin the Big Translucent Dog. Oh, it's horrible. You could see all his digestive system all the time. That would be horrible, wouldn't it? Imagine a clear dog. Ugh. Okay. The properties are graphite conducts electricity. Graphite is soft. Okay. My structural features are graphite has hexagonal rings of carbon atoms. The bonds between carbon atoms in the layers are strong. There are no covalent bonds between layers of atoms. There are delocalized electrons in the graphite. So, graphite conducts electricity. That one connects to there are delocalized electrons in graphite. And graphite is soft is because there are no covalent bonds between layers of atoms.
Final answer?
Yeah.
This question, Laura, question number 4. Can you guess what it's about? It's about
Cars.
alloys.
Yay, I was right.
This question is about alloys.
Alloys are something you can put on wheels.
Solders
Alloys.
are alloys of tin and lead. Different solders have different percentages of tin and lead. Figure 4 shows the arrangement of atoms in pure tin and in a solder. The solder in figure 4 has 6 lead atoms for every 24 tin atoms. Determine the percentage of atoms that are lead atoms in the solder in figure 4.
Okay, 6 lead for every 24 tin. So that is 6 out of 30 equals lead, because it's 6 plus 24 equals 30, and 6 over 30 equals lead. Then if we divide both of that by 6, it's 1 in 5, which is 20% lead.
Final answer?
Yeah. I think that's right.
Explain why solder is harder than pure tin. Complete the sentences. In solder, the layers are distorted. This is because atoms of tin and lead have different
sizes?
Do you want the question mark written down? Or?
No.
This, therefore, the layers cannot easily... It's a good face Laura is pulling.
Break apart. I'm going to go for a help there, Ron. No, it's only 1 mark. But I want to know. Break apart. I'm going to break apart. Okay.
Final answer?
Yeah.
We can't really do... Oh, maybe we can. Figure 5 shows the melting point of... I keep on wanting to read the word soldier.
Yeah.
Real bad.
Especially when you're saying tin a lot. Tin solders.
Yeah, like the Eminem song.
Yeah. Eminem break?
Do you have M&Ms?
No, but we could just listen to some Eminem.
Alright.
Bombing on my sketty already. No, Ron, we haven't got time. Ron, we're only a third of the way through, and I would like to have some downtime today. And we can't play Eminem. Ron, we can't. Right, Ron's had to edit that out, but just know that we jammed for a little bit there to some Dido. We didn't even listen to actually any Eminem. We just listened to a sample of Dido. But it was lovely.
Shows how the melting point of the solder changes with the percentage of mass of tin in the solder. What are we looking at there, Lozenge?
Right, figure 5. We're looking at a chart, a table, a graph. We've got on the y-axis the melting point of solder in centigrade. It goes up to 340 and down to 180. And then on the x-axis, we've got the percentage by mass of tin in the solder. As the percentage increases, it drops right down. So just above 60%, what's that, 62%, we hit its lowest point at just over 180 degrees, where it started up in the like 338s kind of thing. But then once you get above that 62%, it starts to go back up again at a slightly lower rate, but it does go back up.
Yes. Describe what happens to the melting point of the solder as the percentage by mass of tin increases.
I've just done that pretty comprehensively.
Yeah.
For the purposes of podcasting happiness, should we take what I said as my answer?
Yeah, let me just mark it. Okay. What's the next question, eh? What is the melting point of pure tin?
The melting point of pure tin, so, using the graph, so I'm looking at I'm looking at the 100% mass of tin in the solder. So at the 100% point, it is 232 degrees C.
Okay. What happens to the atoms in pure tin as the tin melts?
What happens to the atoms in pure tin
We've
as
got
the
four
tin
answers
melts?
to choose from here.
Yes, right. The atoms gain energy and their arrangement becomes less ordered. That probably would be true. The atoms gain energy and their arrangement becomes more ordered. No. The atoms lose energy and their arrangement becomes less ordered. No. The atoms lose energy and their arrangement becomes more ordered. I don't think so, because it wouldn't cause them to have stronger bonds. So I'm going to say the first one. The atoms gain energy and their arrangement becomes less ordered.
Final answer?
Yep.
Laura, question number 5. This question is about small particles.
I love small particles. They're all fucking small. They're tiny. Did you just do a fart? Where's the guff hat? Don't whiff it at me! Oh, whiff it back on my answer page.
This question is about small particles. Which type of particle is often referred to as dust?
What?
Coarse particle, fine particle, nano particle.
I'm going to say fine particle, probably.
Final answer?
Sure. I don't feel invested in that. We've never talked about that.
It's an interesting question. A spherical coarse particle has a diameter of 4,000 nanometers. A spherical fine particle has a diameter of 200 nanometers. How many times larger is the diameter of the coarse particle than the diameter of the fine particle?
20 times larger, Ron. I thought you were really trying to sniff up your fart then, but it was a yawn. Did you sort of went like...
It's getting in me.
Like, don't let it get away.
No.
That's like the opposite of my old breathing technique. You just kind of like suck your farts back in your body. Fine filtration, like triple filtered wine.
Figure sips
Figure sips.
represents
Sounds like a rapper.
represents
And figure sips.
represents a,
That one smells too. What's wrong with me today? My farts are not normally this stinky.
represents a cubic nanoparticle.
I'd like to change my dust answer to coarse, please, now that we've progressed.
Are you sure?
No. Yeah. Coarse.
Coarse. Okay. Is it because this one says cubic?
No. It's just 3 nanomillimeters or whatever. That
And this
feels
one's a
too...
nanoparticle.
Oh. I'm going to go back to fine. Please, Ron. I'd like to go back to fine.
I don't want to talk you in or out of anything, but I just don't get too hung up on those numbers because you don't know what a nanometer is.
Yeah. I'll leave it at coarse then, Ron.
You're sticking with coarse.
I don't know. What shall I do? I'm calling in a help. What shall I say, Ron?
I'm not going to help you with this one
Fuck off!
because...
I've called in a help. You have to help.
Yeah, no, there's a difference between help and tell you the answer, and I've looked at the answer for this one. That's not a help. That's a tell. You don't get any tells.
I should get a walk. Can I trade my 2 helps for a tell?
And you want to blow that here now, do you?
Fine, I'll leave it. How can I not know what fucking dust is? I'll leave it at fine.
You want to go back to fine?
When we say dust, are we talking the dust I know about, or is there another type of dust?
That would count as a help.
I'm fine. I'm going with fine.
You're fine or you're going with fine?
I'm going with fine.
You're-
I'm not fine. I am coarse.
Not coarse, you want fine.
Yes, please.
Fine particle. Figure 6 represents a cubic nanoparticle. The volume of the cubic nanoparticle is 27 nanometers cube. Calculate the surface area of the cubic nanoparticle. the simplest whole number ratio of the surface area to the volume of the cubic nanoparticle. Use the equation surface area of the cubic nanoparticle equals 6 times the surface area of one face.
What the fuck is happening? Okay, calculate the surface area of the cubic nanoparticle. Okay, that's easy, because that's 9 nano... Is it nanomillimeters or nanometers? Anyway, 9 nm cubed times 6 equals 54 nm cubed. So that's the surface area. Calculate the surface area of a cubic nanoparticle, yes. The simplest whole number ratio of surface area to volume. So the volume would be 27. Oh, it says it there. Oh, but I did work it out myself too. Well done, me. 27 surface area to volume is 54 to 27, so that's quite easy. That's just a 2-to-1 ratio. Simplest whole number ratio of surface area. Yeah, I think it's 2-to-1.
Confident?
Yeah, I think so.
4 marks on the line. Titanium oxide is used in some creams. Which is an advantage of using nanoparticles of titanium oxide rather than normal sized particles of titanium oxide in sun creams?
Okay, my options are: a smaller mass of nanoparticles is needed to be effective. Nanoparticles cost more than the same mass of normal sized particles. Nanoparticles have a lower surface area to volume ratio than normal sized particles. What's the advantage of using nanoparticles? A smaller mass of nanoparticles is needed to be effective. Nanoparticles cost more than the same mass of normal size. Well, that one's stupid. Nanoparticles have a lower surface area to volume ratio than normal sized particles. So does that mean they've got... Wait, nanoparticles have a lower surface area to volume ratio. That would be my guess, because I'm assuming the titanium oxide is in there to like reflect the sun. That's why it's used for sun cream. So you want more surface area, less weight. So, but a lower surface area to volume ratio, I think is then... I'm going to go with that one wrong.
Lower surface area to volume ratio.
But that doesn't feel right. You want more surface area to volume. But a smaller mass of nanoparticles is needed to be effective just doesn't make sense. And the other one doesn't make sense. I think that's the only one that's even vaguely logical. Yeah, I'm going to go with that one.
Okay. Do you want to help?
Yes.
Yeah?
Yeah.
You need one of your helps?
Yeah.
Why would the ratio be different? Just because the particles were smaller, ratios wouldn't change. Also, why the first one? Read a smaller mass of nanoparticles is needed to be effective.
Yeah.
Yeah. So when you're making something for sort of sale as a commercial product, using a smaller amount of an ingredient to be effective would be quite good, because you had to use less of it. So you need less titanium.
Oh, I was reading that sentence wrong.
Yes.
I'll go with the first one, please, Ron.
But you have to talk me through it, so it's not a tell, but it's a help.
Okay.
Why is that?
I was reading that one wrong. So you can use fewer nanoparticles and get the same effectiveness as
Now
cream.
explain to me why. Because you were almost on it before.
Because the particles reflect back off the sun's rays, so you just want a lot of them.
And nanoparticles have...
The same number of same number of surface area.
No.
Same number
They
of...
have... You're right, they need to reflect. if you think in mass, if you have like
More surface area to mass.
why?
Because they're small, but they weigh the same. So it's broken up.
Yes,
So
exactly.
there's more surface area to mass ratio.
Yeah. You get it now.
Yeah.
Yeah?
I just misread that sentence. I read it with the wrong intonation.
I know, that's why I thought that was one where you could do with a bit of a help.
Yeah, thank you.
Titanium oxide contains Ti4 plus ions and O2 minus ions. What is the formula of titanium oxide?
Titanium oxide contains Ti4 plus ions and O2 negative ions. What is the formula of titanium oxide? My options are TiO2, TiO4, Ti2O, Ti4O2. I think, Ron, it would be TiO4.
TiO4?
Yes.
Why is that?
Because I want 2 oxygens. No, TiO2, sorry, Ron. TiO2. Because I want to double the number of negatives. Basically, I want the numbers to add up. So 4 plus and 2 minus. So I want 2 oxygens to mush that. So TiO2 is what I want.
That was a free help.
No, it wasn't.
What do you mean?
I got that by myself.
Yeah, because I asked you to explain it.
Okay, Ron. So I listened to this episode today and I had the notes open so I could add as I was listening. Why is the first note that you've put in the outro, Laura is insane and should die in her sleep?
Because of your weird breathing system.
I tried to open up to you about my childhood problems and you suggest I should die of carbon poisoning in my sleep.
Yeah.
That's not kind, is it?
I was editing this on a train and I really struggled to do all the bits that I need to do. I invariably forget one of them when I'm doing this on a train. I was trying to do the notes and I heard that and I said, Laura's insane. She should die.
Poor Laura. I do think, though, right at the beginning, whispering to you that I've done a fart is peak pre-professional podcasting. That's dead with this era, talking about how stinky all the butt gas is. That's dead. That's gone now.
Yeah, no, that's not what professionals do.
I can't believe, though, we sang along to Dido and you didn't edit it out. You left it in there for me to have to go in and scrape
Why
out.
would we have to edit that out?
Because we can't use other people's music in our podcast.
You can fair use.
No, I don't think you can, Ron.
I think you can.
Well, we haven't. We've edited it out now.
Oh.
My biggest meltdown in the whole exam was over dust. Just sums up science so much.
I don't even remember learning about what dust is.
Who the fuck cares?
Yeah.
Mad. Anyway, I did want to say at this point, if you have any feedback on the exams or the results, we've done one results episode. We have recorded all of them, but obviously we're just about to go into higher tier, so if you've got any feedback on how we've been doing the exams and doing the results that you think we would want to hear before we do basically this again but in higher tier, let us know. Get in touch if you've got suggestions or things that could fruit it up a bit. We might ignore you completely, but you know,
or slut it up a bit, as you kept saying in this.
You were being a slut. It's a big thank you to Catherine Lennon, who invented normal breathing. Before she came along, everyone had sore, muscly necks from constantly having to swivel around everywhere so that you don't breathe in the air that you've just breathed out, and it was exhausting. But Catherine said, no more will you have to swivel like an owl just for oxygen. That's why it's called oxygen, owlsygen. Thank you, Catherine, for letting us all sleep good in life.
Thank you, Catherine Lennon.
Thank you, Catherine. You've saved my bacon.
And what has Catherine received access to recently, Laura, as being a member of our wonderful Patreon?
Well, most recently, my birthday episode, a deep dive into Real Housewives. Ron watched 3 episodes and gave me detailed notes on each franchise.
Yeah, hear us talk about the snootster, 3-head, and fish lips.
Yeah. Oh-wee. Coming soon will be the next Class Clown episode. I've also I've been doing a new thing on my socials lately where I'm doing like deep dives and analysis on comedy. So I've made all of the Class Clown episodes on the Patreon available to purchase individually. Now, personally, I think it's terrible value for money because we're not allowed to charge more than £3 an episode. We only charge £3 a month. That gets you 2 episodes a month. So I think that's better value. But they are there should you not want to sign up, but you are interested in the comedy nerdery.
No, do sign up, though.
Yeah, sign up. Why not?
We need recurring revenue.
My tour starts next week. Oh, my goodness. Next week is October. So please buy your tickets to that. Cheerful Earful Podcast Festival is only a month away, less than a month now. That is on the 20th of October, a lovely Sunday afternoon. Hang out in a pub, and we're going to do a Halloween live episode.
And you'll be covering the moon, and I'll be doing wolves?
I think that's what we said, wasn't it?
Yeah, something like that, eh?
I dreamt last night that Mum had become an orca trainer in New Zealand.
Wow, I love that for her.
Yeah. All right, we'll see you next week. Ron, you have to dismiss the orcas.
What do you say? Oh, pencils down.
Mm-hmm.